Hey, hi there. Yeah, sorry. Well, first of all, welcome. Welcome to these videos. And when I start this stream, I did a little bit hiccup. I pressed the wrong button. I was recording instead of streaming. So let me just repeat myself quickly. Welcome, and this is part 6 of this series, and we are working on the exercise of the Zigling and try to learn Zig. And before we begin, I want to mention that the author of the exercise remind me to do an exclaimer to make sure everyone know that, well, this is the exercise. We are doing the exercise so that it contains spoilers, right? So when you're watching this, if you don't want to get spoiled, pause the videos or try to do the exercise yourself first, or better yet, fork the repository and do the video with us at the same time, right? When I'm working on the exercise, I will try to pause before I work on the actual exercise after we go through the description, so that it gives you a chance to pause the videos and try it out yourself. I will try to remember that. Right, and also you can see right here that I have a Discord server. So if you are like to play along with us and to learn about what we talk about, we talk about this Zig as I'm learning this, and we also do TypeScript, a lot of TypeScript stuff, and a lot of other just programming paradigm and discussion and so on. So feel free to join. And with that, let's get into the exercise. So in the last one, we go through the exercise 50 and 51, and so now we are at the exercise 52. Okay, so we have seen that passing arrays around can be awkward. Perhaps you remember particularly horrendous function definitions from quiz 3. This function can only take arrays that exactly 4 items. Yes, so like this over here, right? It specifies for 4 item array. That's the trouble with array. The size is part of the data type and must be hard coded, right? And so because it's a compile time thing, right? Even you do the underscore, that really just means it is invert, right? During compile time, it's still able to figure out or have to figure out how much space is needed to allocate for the array, right? Thankfully, Zig have slices which let you dynamically point to a start item and provide a length. So yeah, so this, it allows you to do a slice. Right, so as you can see, but how does it connect to this? We're not able to see that yet. But what this means is we're able to get a copy, right, to well, a pointer really to that slice of the array. So this is kind of similar to the Rust concept, right? So digit 3 to 9. So it's not, with this syntax, it's not inclusive, right? So we get the starting from index 0 and stop at and not including 1, right? So that's why you get 0. So here is from 3 to 8, right? And then 9 is not included. This is the open boundary. As you can see, slice xy starts with the index and the last item as y-1. You can leave the y off to get the rest of the item, just like a rest, right? So the type of an array of U8 is that, right? Without defining the length. So that is a slice. Okay. So that is an array, and put the first 4 cards in hand 1 and the rest in hand 2, right? So Basically just create 2 slides, and it shouldn't be too hard. And if you want to try it out yourself, it's time to pause the video. Alright, so let's continue. So for this, it should be 0 to 4. So it's 0, 1, 2, 3, right? So you get 4 items. And then here is 4 to the end. You can go to the 8th, I guess, 4, 5, 6, and 7, right? Or you can leave it up. Right, so that's that. So do a sig build. There you go. Oh, no. Oh, I haven't finished yet. Please lend this function a hand. So now, instead of taking an array, is take a slice. Right? So you don't have to specify the length of the array. Right? It's just a slice. And now this pass. Okay, so slice exercise 2, or the exercise 53. You are perhaps tempted to try slides on strings. They are array of unsigned character after all, right? Slide of strings works great. There's one catch. Don't forget that 6 strings literals are immutables. So we need to change the type of the slides from that to a const. Okay. So yes, that makes sense. See if you can fix the zero wing inspired phrase. This scrambler. What does this scrambler mean? Oh, scrambled great base of oil just belong to us. So we were taking all that, which. Okay, which is what we need to fix. So again, if you want to pause the video right now, go ahead. For us, let's continue. So basically all this is because they are just all really slides. So slides of a string. So all we need to do is make it const. Right. So with that, that should work. It should be easy. Yep, it passed. So before we continue, right, that notice one thing over here, right? Because again, because the reason we do I do this series to learn about Zig is I'm working on the just-func language, and so we also focus on the syntax, right? How the language is designed, right? So over here, right, you can see again that that's how Zig define this array type, or in this case, a slice type, and this become a little bit more confusing because now you have a space between the this phrase or this token. Put it this way, and then you have that. So it makes the code a little bit harder to read, quote unquote, right? But of course, when you are not considering that, right? When you say const, right, it's the same. Just like in Rust. In Rust, you can say let y, and then the type is mutable unsigned 8, right? For example, like this, right? This is the same thing, right? It have a modifier, the mutable in front, and then unsigned 8, right? So the form itself is not that too special, but of course, this would likely throw a lot of people off at the beginning before you get used to it. And also, you know, in general, this when you talk about language design, you know, if we want to keep the language easy to implement or to understand, right? This complicates it because when we tokenize it, when we read this, we need to see, oh, there might be something after this, right? So before we change, right, it would be like that. Right, it was like that. So this is maybe one token. Of course, maybe during the tokenization, you can figure out, okay, this is an array, right? This is a square bracket, close square bracket, and then it's try to process the next one. But when we process the next one, it go back to the same this syntax, right? It reads the first token, and in that first token, it say, okay, I actually might need a second token to figure out what the whole thing is about, because just that is a modifier, right, of the whole type. So you need to pass more. The same thing over here. You need to pass this is a const. Know that this is a const is a special case that you will need to read the next token to figure out what that is. So with that, you know, it's just another additional work or nuances that both the compiler need to figure out, and also, you know, as a consumer, as a programmer, you need to get used to it, right? You need to know that is the case, right? But of course, you know, that's what else you can do, right? One thing is that, say for example, in just-func, right? So maybe I'm just thinking about it right out loud, right? So it could be something like this, right? So this will be the type, right? So it's always in one place, right, like this. Or even if we want, actually it will be an array of in that case I can even do it like this, right? Just like that. So this whole thing is a type, right? And of course that, although there's a space over here, but for just-func, right, this is the based on the position. The first item in this array is the type, right? So there is no ambiguity, right? So but just that's that, right? All right, so let's move on to the next exercise. Exercise 54. Okay, so you can also make pointers to multiple items without using a slice. Okay, so make pointers to multiple items without using a slice. What does it mean? So this is an array, right? So this create a slice, and then this is a pointing to the pointer, and then is I forgot a little bit. Is it an array of pointer? Well, let's continue look at it. The difference between full slice and full pointer is that the slice has a known length. The pointer doesn't. It's up to you to keep track of the number of unsigned X full pointers points to. Okay, let's take a quick look. I don't think it's mentioned over here at the beginning, because in exercise 4 and 5, I don't think we get to the array yet. So this just talk about the array, and then in the pointers exercise, so let's take a quick look. I don't think we touch on pointers of array either. No, we doesn't. So that is the first time we see this syntax. So take a look at the array type to which we causing the same 1 to string. The real nature of string will be revealed when we learn some additional feature. So basically, say just taking what it is. My guess is talking about the UTF-8. So over here, it would also have been valid to cause to a slice. So to basically cast it to a slice. Let's turn this into a many item pointer. All right, so that is basically it's the syntax for pointers to array, although it looks a little bit interesting. Right, it's okay to access Zen many pointer just like an array of slides as long as you keep track of the length yourself. A string instead is a pointer to an array of U8 or slide you have arrays all about, so we would treat a many item pointer of const 8 as a string as long as we can convert it to a slice. Right, because we because we know the length. Please fix this line so the print statement below can print it. So basically, we want to change it back to an that's what we want. Oh, I did that again, right? So I actually not sure what do we want to do over here. It's okay to access send many pointer just like an array or slice as we keep track of the length itself, right? We do know, well, we do know the length over here, although it might not be the actual length, is it? So the length, yeah, it is. So this is 21 character. So that's that. So we can fix this line so the print statement below can print it so that it will treat it as a string. Right. My guess is actually no. Not like that. Not sure. We'll see. All of these pointers things start getting confusing. Cheat sheet. So yeah. My guess is changing it back to this one, right? Changing it back to this type, the original type. So let's see. No, we cannot expect type, but find that. So it cannot, it doesn't work that way. How about we change it to not a pointer, well, this is a pointer. If we want to convert it back to a slice, but if we just leave it like this, well, this won't work, obviously. So this is the original code, so this won't work either. So if we don't do anything, of course, this is not the right answer. Right. Why does it have the length of is a compile error? Did I do something weird? Well, of course, it's something I did something weird, but this, why does it? Oh, probably it's because over here it is it goes this okay, it goes all the way over here, but when the standard debug prints try to print it out, because this doesn't know the length, so then that's why this wouldn't work, right? So what should we do? It's not this. Obviously, it's not that. But so we do know the length, right? And then it is a string. How do I force it to tell that I do know the length? Right, because I feel like that is the right answer. Well, that is the same type as it started with. How about get to this, and then instead of doing that, we specify the length like this. All right, so that's how we do it. The type is still a slice, so this is really not a string, it is a slice, right? So that's what here, what it means over here, that is converting it back to a slice, right? So this is a slice, and in order to convert it, we specify exactly, we try to get out a slice from this pointer, right? So that's how it's get done. All right. Okay, makes sense, right? Because this, so it seems like the type is specified over here for this variable is a straightforward type declaration, right? So it doesn't do any, so the compiler would not do some automatic type cast for you, right? So I guess it makes sense, because maybe at the C, C, say Rust level, it will not do this kind of automatic conversion. It's not like Java in C# or in JavaScript, right? So it's explicit. So this is just a type declaration. So that's why it doesn't know how to convert it. And of course, with a string pointer try to cast to a slice, that doesn't make sense, because the compiler doesn't know what's the length, right? So we need to specify it. But the same thing is when it's tried to, well, about the type declaration part is when we declare like this, the compiler doesn't know that, oh, I would need to just cast it or get a slice automatically and then put that into an array. And that also, yes, now I'm thinking of it, that doesn't make sense, because in Sig, the array type is a constant type, is in compile time, right? But this definitely do this casting is not a compile time thing, so that wouldn't work to begin with, right? If we declare the type over here, this need to be inferable, I guess, right? It need to be able to figure out during compile time how much, how long it is, and also what's the value in it, so that it can bake it into the program, right? It's not a vector or something, right? So that's why you have to do this. This have to be a slice, and here the solution is to make it to define the length. All right. Hope I didn't make you more confusing, right? So let's move on to the next one, exercise 55. So 55, a union, right? So we get to union. That's this would be interesting. A union let you store different types or size of data at the same memory address. So how is this possible? The compiler set aside enough memory for the largest thing. So I know in C it also have something similar, although I don't really have much experience with it. I just heard of it. I saw some code like that, but never do that myself. So in this example, an instance will always take up unsigned 64 bits because that is the largest. This syntax just looks like a struct, but foo can only hold small or medium or large value. Once a field becomes active, the other inactive field cannot be accessed. To change active field, assign a whole new instance, right? So you won't do any casting or anything. You just put a new thing into it, right? You cannot. It's not modifiable. Okay, is there any reason that why it is not modifiable? My guess is for some optimization. But again, I don't know too much about it. If any of you knows, please feel free to leave it in the comment or join the Discord and share it with us. So. Unions can save space in memory because they let you reuse a space in memory. They also provide a sort of primitive polymorphism. Right, so that is a it is an interesting concept to do it that way. Yeah. Although it's not really polymorphism because for one obvious reason. In real polymorphism, right, you cannot predict what your subclass will contain, right? It can contain a lot more things than the base class. But in here, you can't really do that, right? Because the size is predetermined, and also the subtype, quote unquote, is predetermined. Unless we talk about the come time, which will come later on, right? So here, foo bar can take a foo no matter what the size of unsigned integer it holds. Right, okay. Oh, but how does foo bar know which field is active? Sig has a neat way of keeping track, but for now we just have to do it manually. Oh, do it manually, okay. So let's see if we can change this working. We've just started writing a simple ecosystem simulation. Okay, insects will be either bees or ants. Bees store the number of flowers they visit, and ants just store whether or not they're still alive, right? So that's fine. So we'll have two fields. Hold on. That doesn't make sense. No, the exercise doesn't make sense. Maybe this is something that I should bring it up. Because if it is really a union, meaning it is either a unsigned 16 or a boolean. But then that means the bees, which store the number of flowers they visit, doesn't have a field still alive, so the bees can live forever. So I think the example has some problem over here, but it's okay. Let's move on, and I'll raise a issue in the repository. Since we need to specify the type of insect, we'll use an enum. Okay, bees of n, A or B. A for ant, B for bees, I guess. Right, we will just make one bee and one ant and test them out. Right, so the ant is still alive. The bee have visited 15 flowers and print it out. Oops, we made a mistake here. Ant or bee dot C. guess is we need to change that, need to pass that in. So yeah, that's it. So if you want to try it out yourself, feel free to pause right now. If not, we'll continue. All right, so on this should be straightforward. Just this is A, this is B, and that's it. Yep, that's what that is. So just need to specify the right type. So again, so what it is, N or A or B. So it's here is, that's what it means by doing the exercise. That's what the exercise mean doing it manually, because this is being passed in, and we are manually passing in, telling the code that this is an AND or it is a B. Right, that should be a better way to do so. So although it's already 31 minutes, but since we are talking about the union, let's see if we can finish this too. Yeah, let's push for it. Okay, so exercise 56 is really quite inconvenient to manually keep track. Yes. So there's a tag union. So and then so over here you can tag small, medium, and large, right? So that's how you use it. And now we can switch directly. And if the F is small, right, it is a tagged union. So if it is small, then you get the value inside the small and do something with it. Right, so compare that to here. Here is just say you get the type and then you access this over here. Right, so say insect.still alive. So actually with that, if we change this, what will happen? Right. It's probably, yep, it crashed in runtime, because in the compiler is not able to tell that you did something wrong, right? Because it's not a tag union, and the compiler at compile time doesn't know what values this contain at runtime. Right, so that makes sense. So over here, let's make an inside a tag union. So it already does that. So then that's fine, and as simple, could it really be as simple as passing the union? So let's try out, and my guess is yes, it is. And so switch insert. Right, so there you go. So let's also do the next exercise with tag union. It gets even better if you don't have a need. If you don't have a need for separate union, you can define an inferred enum. So just put the enum keyword. Okay. So then that should be simple, right? So just change this to enum, and then the rest would be the same, right? So infer enum are neat, representing tips of the iceberg of the relationship between enum and unions. You can actually cause an union to an enum, which gives you the active field from the union as an enum. What's even wilder is that you can cause the enum to a union, but don't get too excited. That only works when the union type is one of the weird 0-bit type. Cause an enum to a union. The 0-bit type probably is because it only contains a value, because at the enum space you do not have other way to specify what kind of information it will contain. So that's why it cannot contain anything, can only contain the type. So that's why that is the case that you can convert. Tag unions, as with most ideas in computer science, have a long history going back to 1960s. However, they are only recently become mainstream, particularly in system-level programming language. Right. So it is, well, it is true. It become more mainstream, and that is one reason is because the rise of functional programming. Right. Again, the idea of functional programming has been around for a very, very long time, right? And when it get mainstream, people start to realize the benefit of functional programming, and along with it is this tag union. So in TypeScript, this is basically the same as discriminate union, right? So you were able, at the type level, you were able to determine which union it is by using that type discrimination. So what I mean is that, so you have let's say you have a type X, right? So the type X is, you have a type X, and then with something else have a equals to a number, and then you have a type Y equals to type is a Y, and then B as a string, for example, like this. And then you have a union type, which is X or Y, right? Like that. And then if, say let Z is a type U, and if C dot type equals to X, or X over here, then the TypeScript compiler will able to figure out, hey, because this type is X, and in this union, the type can only be this X or Y, so it knows that we are dealing with the type X. So over here, you will able to use z.a. Right? If you specify as a Y over here, I can't type Y over here, then you were able to say z.b. Right? That's what discriminate union means, and that is the same idea that we see here in the tag union. Okay, so for the quiz, this seems to be quite a long quiz, so we will work on that next time. And so let's conclude this stream here. So let's go back and review. So what do we have learned in this video? Right, we talk about the slice. Right, the slice basically able to slice, get a piece of the array. So it's a very nicely named type, and the syntax is just like an array but without specifying the size. So that's also great. And then we can do the same thing. We can use a slice on strings, right? But it has to be constant because strings are constant, right? And then we can deal with pointers, right? So over here, what we need to do is to tell the compiler to say, hey, this the string in this pointer, I want to get the first 21 characters, right? And we know that because we defined it over here. Then from there, we were able to extract a slice out of the pointer. That's why we can use it to print. Right? And then for the union type is pretty basic. This one, I'll definitely bring it up to see if Reg Factor can improve this exercise. Right, but essentially what it means is it's a union. You can store one. It will allocate the largest memory that any of one of this type will contain, and then you can put in anything. Either of the value or one of the values inside the union. Right. And you, besides here, you can do it manually, but most of the time you will do that using the tag union, right? Specify enum, or better yet, if you don't need to use it elsewhere, don't need to use that enum type elsewhere, you can just specify it like this, so it will automatically do that for you. All right, so that's it. I hope you learned something and hope you enjoy this video. So again, if you like these videos, feel free to give it a like and subscribe. And also, yeah, one thing I forgot to mention is, turn on the notification. So because for myself, my schedule is a little bit chaotic and I try to work on many different things, so I haven't able to find a static, or a regular time to do the streaming. So you will see that I start doing a streaming, sometimes suddenly in the midnight or sometime in the evening, like this one. And so turning on the notifications will get the notifications for the streams that I'm going to do. I try to give some heads up ahead of time, but I'll try my best to do that. And then another thing is join the Discord, which I will share more information over there. Right, with that said, again, that's it for this video, and hope you will like this and learn something from it. Right, bye.